Hello Centenniers, welcome to Centenneering. We're going to do a practice problem. I'm kind of jumping the gun a little bit because we're on chapter 3 in the book that I'm using and we're already on problem number 35, unless I decide to go back. But anyway, so the viewing window in a diving suit has an area of roughly 65 centimeters squared. If an attempt was made to maintain the pressure on the inside of the suit at 1 atm, what force would the window have to withstand if the diver descended to a depth of 150 meters? Take the specific gravity of water to be 1.05. Okay. So, how can we approach this problem? So, this is my best attempt at drawing a diver suit, and this is the cross-sectional area that they're talking about of the viewing window in 65 centimeters squared. And the pressure should be 1 atmospheric, which is the pressure that you're feeling about right now. And the height, or the depth, that this person is at is 130 meters. That's a very, very deep, that's a lot of pressure. So it must really, really withstand quite a lot of pressure. And the specific gravity is a little bit more than usual because the density increases with depth a little bit. Okay, so I challenge you to try this yourself, but what should we do? So pressure, we know, is force over area, and that is also equal to rho GH. Okay, so we know the cross-sectional area, we know the gravity from specific gravity. Sorry, no, we know the gravity as a gravitational constant, we know the density from specific gravity, we know the depth, and we're trying to solve for force. So simply rearranging this equation will give us force equals rho GH. Okay, so all we have to do is plug this guy in, and we're going to have force is equal to density. So we know the density from the specific gravity. So the specific gravity is given as 1.05, and from the specific gravity video, we should know that this equates to 1.05 grams per centimeter cubed. And if you do some conversions, this will convert to, just multiply by 1,050 kilograms per meter cubed. I challenge you to multiply by some conversions to see if you get the same thing. So the density is 1,050 kilograms per meter cubed times gravity, which is 9.8 meters per second squared, times the cross-sectional area, 65 centimeters squared, times the depth or the height, which is 150 meters right here. And all we have to do is cancel out this centimeter squared with the conversion factor of 100 squared centimeters squared per meter squared. Okay, and these should give out the correct units as we've seen in the last video, but I'm going to do it one more time. So centimeter squared cancels out, meter squared and meters cancels out with meters cubed, and we are indeed left with kilograms times meters per second squared, which is newtons. So all we have to do is multiply this guy out. So here we have 1,050 times 9.8 times 65 times 150 divided by 100 squared. So that is pretty much 1 times 10 to the 4. So the final answer is 1 times 10 to the 4 newtons. It also asks for it in pounds for, so you can simply convert using 32.2, but I kind of don't want to do that because I did a bunch of those in chapter 2. Alright, that's it for this video. Don't forget to share this with your friends, family, and your dog.